All right, so this is border problems. I think this is now part 4. Feels like it's about part 50 if you've been watching all of it. Um, but the last 2 problems are the ones we're going to get through right now. So, jumping right into it. Mrs. Beata has a rectangular garden in her backyard. The area of the garden is 500 square feet. She wants to put fencing around the garden so no animals get in. Okay, the length of the garden is 5 feet longer than the width. So this is a type of problem where you only have one rectangle. There's the garden. It says the length of the garden is 5 feet longer than the width. So how wide is it? I don't know. X. How long is it? X plus 5. Okay. And it says the area, right, this whole area is 500 square feet. That's it. There's no extra border problem here other than the whole border of the big rectangle. So we're going to do length times width is equal to the area. So x squared plus 5x equals 500. So x squared plus 5x minus 500 equals 0. Let's see here. 10 times 50. No, that's not going to make any sense. I'm trying to do this really quickly, and I feel like there it is. All right. So x and x, we have 20 and 25. I need a positive and a negative. All right, so negative 20 times positive 25, that works, that works. All right, so this is still equal to 0. So x is equal to 20 or x is equal to negative 25. By this point, I am hoping you recognize that negative 25 makes no sense, so eliminate it. It's an extraneous solution. All right, so we now know that x is 20. So that tells me that this side is 20, this side is 25. It says, how much fencing must she buy to construct the fence? Well, to fence this whole thing, you're talking about perimeter. And the perimeter would be 20 plus 25 plus 20 plus 25. So let's see what that gets me. 90 feet. All right. So she would need 90 feet of fencing to go around her garden in the backyard. All right. Problem number 10, last one here. All right. Mr. Wallach wants to frame a picture of his dog. Oh, how cute. Okay. So let's say picture. Picture is 15 inches by 20 inches, and he wants to put a frame of uniform width around it. All right. So let's frame this thing. So uniform width, call it x is all the way around. Okay. So let's get some outside dimensions here. This would be 15 plus 2x. This would be 20 plus 2x. If the area of the frame, all right, so I'm going to go ahead and zoom in on the picture here. The area of the frame is 200, and let's figure out area of the picture here. I feel like that's 300, and let me double check. It is. Okay, so using this information, let me build an equation here. The large rectangle, so 15 plus 2x and 20 plus 2x would equal the picture, the little rectangle, which is 300, plus the frame, which is 200. All right, so we've got an equation to solve now. So this is going to be 300 plus 30x plus 40x plus 4x squared. And I'm going to leave that as it is for a second because I'm just going to come through here and eliminate the 300s. I'm lazy like that. All right, 4x squared plus 70x minus 200 equals 0. Divide everything by 2. Okay, that'll at least make the numbers a little smaller to work with. Okay. Let's see if I can factor through this. By the way, if factoring is not your strong suit, feel free to solve with the quadratic formula. That's totally fine. What you just want to make sure that you're doing it is at the end, still pay attention to the fact of which one of your answers is positive versus negative. Let's see. That would be positive 40 and minus, let's see, 2x squared, 40 minus 5, and then, yep, that works. Okay. So let's see. X is equal to 5 over 2, or x is equal to negative 20. I'm going to take all of 3 seconds here to cross out the negative 20, because, yeah, that doesn't make any sense. Let's see. What was the question in this problem? How wide is it? So, how wide is the frame? Well, the frame is going to be that uniform width, and I'm, completely lazy, and I could say 5 over 2 inches. If I wanted to turn that into a decimal to make, the world a little bit easier to understand, that would be 2.5 inches. You do not have to give me both of them. I'm completely happy with 5 over 2. All right, so that's the end of all of the border problems on this worksheet. I hope that this has helped put some understanding into all of the different kinds of border problems that there are. And again, don't focus on learning one method. Turn it into something that's a little bit broader of take a look what's in the question, draw a picture from that. From the picture, create an equation, and then solve the equation. Sometimes you'll get quadratic, sometimes you'll get linear functions. Let me know if you have any questions.